Okay, so should I start now?
Yeah.
Okay, thank you. Thank you for inviting me to talk something on the International Space Station and Canada's contribution to this space station. Sorry? Okay. Okay, so firstly, humans are going back to the moon. And this is a unique mission where human are not just going back to the moon, human are making a lot of contribution uh, to the deep space. We know in Apollo era from 1968 to 1972, NASA launched 9 human missions. And in these 9 human missions, 6 were successful. And from these 6 missions, 12 men walk on the lunar surface. So, uh, so uh, to 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 tell you why this mission is unique and why it is important, because this is not just going to the moon. In this mission, actually, human will have long-term presence around the moon and on the moon, and it will prepare us to have a more complex human mission to Mars. So the mission, what we are going to start, actually, we have already started, that mission will lead us to Mars. And the name of this mission is Artemis. Uh, in this mission, in this Artemis mission, we are not just sending human to the moon, we are also building a dedicated lunar station, which is known as Gateway, and it is 938,000 kilometers away from Earth. So you can understand this is in deep space. And once this ignited, there is no going back. So here you can see there are actually series of Artemis launch. In this Artemis launch, the first is already launched, and you can see a video over here. Let me play this video.
And here we go. And hydrogen burnoff igniters initiated. 7, 6, 5, 4-stage engine start. 3, 2, 1. Boosters in ignition. And liftoff of Artemis 1. We rise together back to the moon and beyond.
So in this video, you saw that the Artemis 1 was launched, and when it's launched, they have announced that back to the moon and beyond. The reason is this mission not just only taking humans to the moon, but it will eventually take us to the Mars. So the next target of human mission in deep space is Mars. And with this Artemis mission, we are actually sending humans, and first time and Canadian astronaut will walk on the moon. So this Artemis mission takes a unique halo orbit. The reason of halo orbit, it's a unique orbit where it's actually an ideal hub between Earth and beyond. So if man wants to have more mission from Earth to the moon and to the Mars and beyond, this is going to be a unique hub. In conclusion, what I'm trying to say about Artemis is taking human again to the moon, but they are not just taking human to the moon, but they are making a new international space station, which is known as Gateway, a dedicated lunar station in deep space. And from that station, actually, human can reach to further in our galaxy. And what's the Canada's contribution to this mission? The Canada's contribution is known as Canadarm. So in this mission, over here, you can see the International Space Station, which will take the halo orbit at the rightmost top right picture. This is the International Space Station, and you can see there is an arm on the space station. This arm is known as Canadarm. So Canada is building this arm, and it's actually built in Canada's soil. So in our office in Toronto, Brampton, we are building this arm, and in Artemis 5, we are going to launch this arm. As you have seen in the previous slide, we have already launched Artemis 1, like NASA. Mainly the whole project is led by NASA, right? And different countries and different space agencies, they are building different modules. So from Canada, we are building the Canadarm3. Canadarm3 is also a very unique part because this is the only moving thing with respect to the International Space Station. Like whole state ISS, I mean, International Space Station is known as ISS. Whole ISS is moving in its orbit, but with respect to the ISS, this is the only moving part. And it can do a loads of things. As you see in two pictures, astronaut can do spacewalk by this by the assistance of this Canadarm. So in one side of the Canadarm, they attach their legs, and the other side is attached with the space station, and they can go further, or if they have to go to a certain position in the space station, outside of the space station, they can go by this arm. This arm also helps to dock some other modules in the space station. So for an example, in Artemis 5, I believe in Artemis 5 or Artemis 6, we are going to launch this Canadarm. And when it launched and attached with the main station, the next modules, it can help the modules to dock properly. As you see below left side picture, over here, one module is captured by the Canadarm, and it is taking towards the space station, towards the space station. This is an autonomous arm. It can do many work automatically. However, there is a control over it, and astronaut can control it from the ISS, and also the ground station can control this arm, and that will be controlled by MDA, our office from Canada, Brampton, GTA. So this arm actually can walk around this whole space station. Like the one part is attached, another part is moving, then the other part is going to attach in one position, and the other portion is going to another point. So this arm can actually walk through this space station. Okay, and this is a video I would like to play, which I believe very relevant for our audience. In this video, you will see, you will hear the voice of a director general from NASA, and also you will see how many departments needs to collaborate to launch a mission. So you'll see in each, before launching anything, each department were asked that, are you okay? Like each department needs to say a go, so that the final call can be made and the mission is start, and the Artemis started, or any mission started. So let me play the video and you will see how actually it works.
The long-range purpose of unmanned exploration of the planet is the development of technology which will lead to eventual manned exploration. Power, go. System, go. Propulsion, go. Avionics, go. Flight software, go. Scientifically, our objective is to assist in answering two basic questions. What, if any, life forms exist on the planet, and how has the solar system been formed? Telecom, go. Fault protection, go. Uplink, go. Phase lead, go. 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 Go.
So you can see actually how many departments needs to collaborate and come forward to say the call, go, and ultimately the mission starts. So what's the core messages from here? The core messages is we need people from different departments. So do what you love to do. It doesn't matter, you don't need to be an astronaut to contribute in the space industry. Do what you love to do, focus on what you're good at. If you have passion for space, there is always room for you and for your work. But whatever you are doing or you love to do, try to understand the basic principles and try to relate it to the real-time problem. There is no shortcut. You have to give your time to understand the basic principle and always try to relate it with the real world problem. Remember, for an example, for me, I'm working in the avionics unit. So when the call for avionics is going to made, like when they ask for avionics, we supposed to say go. To answer it as go, we have to do a loads of things, right? So I don't need to be an astronaut to contribute in the space industry. I'm an electronics engineer, and that's what I love to do. So I'm doing that. And even I know loads of people from biology. They are not even in engineering. Biology is a different department in science. And we have a lot to take from biology department. It's just an example, but the core message is what you love to do, do that, and focus on what you are good at. If you want to contribute in the space industry, there is always room for you, but there is no shortcut. You have to give your time to understand the basic principles and always try to relate it with the real world problem. Now, this is the big video. Once I was thinking to take information from this video and present it here, but then I found out that this video is so much organized in a way that if you want to know the Artemis mission, the new mission which will take humans to the moon, this video will give you all the information. Then if you have any question, of course, I'm going to answer. But this is a very nice video to show you how actually it prepared from the very beginning to the very end when our astronaut is going to land. And remember one thing, this is the first time a Canadian astronaut is going to walk on the moon. So this is very important for Canadians and a very proud moment. And not all countries are giving an independent module in this new gateway or new International Space Station. Only a few, and Canada is one of them. NASA, Canada's Canadian Space Agency, MDA. There is JAXA from Japan and ESA from European Space Agency. So they are giving the independent module for this space station. So let's watch this video, and it will give you all the information you need to know about Artemis or our new mission.
Between 1968 and 1972, America launched 9 human missions to the moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here, we must first do here. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind, the astronauts. This is their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and fuel reserves. And a launch abort system, with engines capable of pulling the crew module to safety during launch should anything go wrong. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, thundering our crew upwards. 2 minutes after ignition, the solid rocket boosters are spent and released. 8 minutes after launch, the core stage is depleted and separated. The upper stage fires briefly, placing Orion into a parking orbit around the Earth. Here, the crew reconfigure the spacecraft and check systems to confirm everything is ready for deep space travel. With a go from mission control, the crew reignites the exploration upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also put Orion on a course that will intersect the moon days later. Once this burn is complete, the upper stage of the SLS is jettisoned and the crew aboard Orion coast for several days toward all that awaits them at the moon. Approaching the moon, we see the fundamental differences between Artemis and Apollo. Instead of requiring Orion to serve as an expendable lunar command module or to carry a constrained lunar lander, the Artemis missions will take advantage of a different approach, pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners. This includes rovers, science experiments, and human-rated systems on the surface. But it also includes a dedicated lunar station in orbit around the moon called Gateway. Here at this station, we can pre-stage a robust lunar lander and establish a strong communications relay. Designed with open standards, the Gateway can be expanded as new missions and partnerships develop, allowing multiple human missions on the moon at the same time and enabling ongoing science to be conducted even between human missions. The Gateway is also capable of adjusting its orbit to allow access to every part of the moon, something the Apollo missions could not do. But the real key in this approach is placing Gateway in a unique halo orbit to perfect the maneuvers needed for Mars missions. And with the growing list of commercial and international opportunities, Gateway is the ideal hub between Earth and all that lies beyond. Returning to our crew as they approach Gateway, the Orion must match the elliptical orbit of the station in order to successfully dock. Once on board, pre-selected crew members transfer to the lunar lander, while those assigned to Gateway remain on station. The lunar lander system itself is built for 3 unique steps: descending from the halo orbit of Gateway down to a low lunar orbit, descending from low lunar orbit to the surface, and once the lunar mission is completed, launching from the surface of the moon and ascending all the way back to the orbiting Gateway. Once back aboard the Orion spacecraft and undocked from Gateway, the crew fire their engine once to break out of the halo orbit and once again to sling the spacecraft around the moon, placing it on a multi-day trajectory back towards Earth. As they near the end of this journey, the service module is released and the crew module is oriented heat shield first. Entering Earth's atmosphere at 25,000 miles per hour, the friction of air slows Orion considerably, while also subjecting it to temperatures of 5,000 degrees. With the Orion now at just 300 miles per hour, a series of parachutes uniquely tested and produced for this moment deploy, decelerating the craft to just 20 miles per hour for splashdown. With each successful mission, Artemis ushers in the next wave of men and women to explore our moon and prove that together we are ready to go beyond.
Yeah, so that is all about our Artemis mission. And at the very end, I'd like to share some surprising space facts. So the fact is, all of the equipment launched in the 55 years history of space program equates to less than 1 day of worldwide auto production. This is very surprising, right? 55 years, and here's just 1 day of auto production. So what's the conclusion from this fact? So the conclusion is that at a fundamental level, statistical process control principles associated with mass production do not apply to the space business. Because this is a unique business and the production, research, and development all are unique over here. And what's the lesson? The lesson is the space workforce is fundamentally a craft-based skill where key knowledge is passed from generation to generation. That doesn't mean that it comes from father to son. It's actually like in the space agencies or in the space business, this knowledge is passed from the experts to the youngsters. For an example, if I talk about myself, I didn't join MDA Space as at an entry level, but when I joined, they gave me a mentor, and I found why it is important. They teach us how to deal with a problem, how to see a problem, how to push the boundaries, how to address a problem, and how to have the solution for a problem which was a threat previously, and now we make it an opportunity. So all this thing, there is a specific way to learn, there's a specific way to address. These kind of knowledge comes from a generation to generation. And it is very important to understand all the basic principles and how to address a problem. Initially, a problem may show in a way that it seems impossible, but you have to address the problem in a way that it can benefit you and the mission. Okay, what are the core messages? The core messages is reality is much more complex than theory, and it takes time, become an expert to translate the principles, physical principles, into a high voltage art, i.e., you have to relate the principles to the real world problem, and it takes time and patience. Practitioners must have a broad understanding of physics, engineering principles, materials, technologies, if reliable, optimal design are to be achieved. I'm from engineering background, that's why I'm talking about engineering principles, but it's applicable to all background. And sometimes you may not have to do a mass production at the very end of a year. You may have to develop just one design, but you always have to be in the forefront of the industry and know the cutting edge technology, always do research and development. And that's how you can push the boundaries for the humanity, for the betterment of the world, and reveal the unknown of the universe. Thank you for your time to listen to my presentation. Now, if you have any question, I'm happy to answer. Before going to the question and answer session, one thing I'd like to inform that all of the information, data, videos I have presented here is either from a public domain or I have permission to share it. Yeah, and even in the question and answer session, three things can happen. One is you ask me a question, I'll give you the answer. Second, I cannot provide you the answer because I'm not allowed to provide the answer. And third, I cannot provide the answer because I don't know the answer. So yeah, so that's the end of my presentation, and you're free to ask any question if you have, or if you want to discuss something. Thank you.
How does someone get into this type of career?
So it depends, right? If you have a passion for space industry, and you are very good at your field, you can end up in this industry. You can build your career in space industry. For an example, we need biologists, we need chemist, we need electrical engineer, we need electronics engineer, we need even weather expert. Of course, we need astronaut. So it doesn't matter which field you are in, it matters that you understand the principle and you have passion for space. So yeah, and to answer this thing, one more thing, I would like to tell you that uh, you you really should understand the principle, like not just read for your exams or not just read to get marks or pass things. You have to understand the principles and you have to try to relate it with the uh, real world problem. Try to relate the principle with the real world problem. So do what you are good at and do what you love to do. Yeah,
I have a question.
sure.
So, like the astronauts, what training they have to go through to be accepted to go to the moon or Mars?
Okay, so they have specific sets of training, but there is no specific study for like from bachelor for astronaut. Like for an example, uh, uh, aeronautical engineer can end up being an astronaut, and electrical engineer can end up being an astronaut. So you first have to be good at your field. Then if you have that uh, target, there are some certain training and certain fitness thing that you have to make sure you have that, and you have to apply, like for an example, after your bachelor you can pursue uh, for that field, and there are specific training specifically designed for astronauts, so you have to follow that route. However, as I have said, astronauts are the ones who actually land on the moon, walk on the moon, and go for in the deep space. However, uh, in the space industry, they are not just the one who involved in the development, research, and everything. Okay, so yeah, if you want to be an astronaut, you can go for it. There is no, as far I know, there is no bachelor degree for specifically designed for astronaut. You can do whatever you like to do, then you can follow that route to be an astronaut. There are specific training, specific session exams for astronaut. You can find more on NASA websites. I know even in our office, at present we are not doing, but previously we trained astronauts. And to just give you an example, we have actually in our office, we actually have a simulated spacecraft. Like if you go inside, it seems like you are inside a spacecraft. Of course, it's not zero gravity, but everything, the design and modules and everything is in the spacecraft. So when they gave training, actually they took the astronauts or the people in that module and they knew those things. There is another thing I'd like to tell you. We have another branch called SIMFAC. So it's actually in the Artemis program, it's actually collaborated in a way to the space station that if there is any problem happened over there, we'll have same problem in the ground. So it's sync up in that way. And if we solve that problem over here, it will be solved over there. So these two things, two electronics are synced in that way. So yeah, if you and I think at grade 9 or 10, they invite students to our office to see all these things. Yeah, there are specific dates you have to know. You can find it in our website, mda.space. You can look at it. Yeah.
What kind of subdivisions are there?
What do you mean by subdivision?
Like types of careers in space?
Types of what?
Like what could you do in space? So like what kind of careers are there?
Oh, there are a lot actually. As I said, like you can come from any background. For an example, I came from electrical and I'm actually an electrical and electronics engineering. My expertise in electronics engineering, signal processing, and radiation. So what I am doing is how to put it in a simple way. Like the environment in the world and in space is completely different, right? In space, you have a harsh radiative environment. So the electronics, how it behave in our world, it's not going to behave the same way in the space. So what we are doing, we are trying to characterize the different electronics component in a harsh radiative environment, right? So we bombard our electronics with actually we create a space environment, a radiative space environment. We put our electronics over there, and we are trying to characterize how it behaves, right? So if it sustain and work perfectly fine, on that time we use these electronics to build spacecraft, to build a module. Okay, so this is from electronics background. Now we need weather expert, because weather expert will tell us what kind of harsh radiation environment we will have in the space. And if you are interested, you can search sunspot and you can see actually live how the sun actually behaves. The space weather is controlled by, well, I shouldn't say controlled, is it's like influenced by sun. So if sun is like very harshly behave, we have so much energetic particles which can damage our electronics. So we need weather expert over there. Then we need biologist, how these environment, these space things will affect our astronauts. They need to come up with some idea how to protect our astronauts from this harsh environment. So you can see, like, it doesn't matter from which background you are. It matters that you have passion for space and you want to contribute in the space, and you can do it. So, but the main point is, whatever you are doing, what you love to do, you have to do it in a very like not just for marks and passing exams, right? You have to understand the basic principles, and you have to relate it with the current world. And from all background, almost from all background, actually you can contribute in the space industry. Yes.
Manjur, so if I see your video, that will be much better to
Oh,
understand.
sure. Yeah, sure. Why not?
Okay, so yeah, now they can see the real astronaut engineer. Okay.
Oh no, I'm not an astronaut, by the way. I'm completely an engineer.
Yes, you're supporting that team
Yeah, I'm
to
supporting.
function it perfectly, right? Yes.
Yeah, that is correct. Yeah.
So though you see that everybody can contribute in space engineering, but one question: if some parents or the children, how we are going to guide them? Let's say they finish their high school. In grade 7 and everywhere there's some sky science. We know that curriculum will have that. It's fine. But after that, when they are, is there any university course? I know in Montreal, maybe in Montreal or in Waterloo University, there's called aerospace engineering. So what is your recommendation? Which program will be better for students who like to work as an astronaut?
If you ask me who wants to be an astronaut, then the answer is one. If you want me to answer it for space industry or contributing to the space, that's different. Because for astronaut, like if somebody, even for astronaut, actually, from
Right.
many background you can come. But of course, you have to be very cautious about the current trend and current industry of the space. Like there are lots of things in public domain data from NASA and from ESA, from CSA, from MDA. They provide for the general people. So you can read many things and you can know actually how things are going over there, like what actually the astronauts and the engineers are doing in terms of space industry. So you can be updated like you can update yourself with that. And of course, like aeronautical engineer, navigations, these are very closely related with the space industry. Also, I believe in the university, you can take some optional courses, like some are fixed, like if you are doing, for an example, electronics engineering, you have to take these courses. And there are some courses, optional courses that you can take, like 10 optional courses in your 4 years. So of course you can take the astrophysics or the fundamentals of space physics, this kind of course. Many universities offer, I know Waterloo, Quebec, McGill University, even UFT, I guess. I didn't specifically search for it, but of course there are some courses which is much more related with the space. As an optional course, you can take those courses. At present, exactly, I can't pinpoint in any specific university or any course, but of course there are loads of courses. And also, as I said, if you dig through more documents and the videos and what they are doing, what NASA's doing, what CS, Canadian Space Agency, CSA is doing, what MDA is doing, you can see actually what trend they are following, right? What kind of work they are doing. So from there, you'll get an idea, okay, to understand this thing, I have to take these courses. Like you see a video and you don't understand many keywords or many 10% of the video you didn't understand. And then you found a course outline. Oh, I want to know these things because I saw this thing, these keywords in that video or in this document. Then you can choose that course, of course. But it's important to do what you are love to do, what you are good at, and try to understand the fundamentals, try to relate it with the current world. Yeah.
Rishi, next question. Do you have some question also, right? I'm sure.
I don't have any more questions.
Labib,
Make the question answer.
yes, please.
Is there an age limit to, like, for example, if NASA's taking astronauts, is there an age limit to them? For them? I mean,
Means he would like to join now. If there's an opportunity for him right now, he's great. By the way, he's grade 5. He would like to join right now.
Well, of course, in grade 5 or in your age, there are some programs for NASA, but I'm not sure whether at grade 5 you can go outer space. I don't exactly know if there's an age limit or not, but I know that you need to be physically very fit to go there because it's a question about billions of dollars. We try to make sure that we don't risk our astronauts and we don't risk their health. We also don't want to risk any of the equipment. That's why actually, if you want to know, the test what we are doing for our electronics, it takes millions of dollars just to test few components. And we are willing to spend this much dollar because there is no coming back, right? Once you launch something, it's already there. You can't just go to a car. You can go to a car and replace one part, but you can't do that like normally for space. Of course, the astronaut fix few things. We can fix few things, few softwares from here. But in general, we are always try to follow a step where we can make sure everyone and everything is secure. To do this security, to make sure you are okay or the astronauts are okay, there could be a age limit. I don't know exactly, but I know in terms of health, you need to be perfectly fit to be there. And also, you will work zero gravity. You will work in an environment where there is zero gravity, right? So in zero gravity, it's something different. Like you can't just lay down to bed. You can't just do regular stuff over here. Even the astronauts need to do some exercise over there, and their exercise bike and everything designed differently. And in YouTube, I guess you can find some videos like the astronauts' beds are like one is in this direction, one is back direction, another this direction, and another is in this direction. So in all sides, because there is no ground, right? You can't say, okay, I'm lying down in the ground. No, all are like floating, right? So to address this thing, of course, you need a specific health
Oh.
standard.
And I also heard this thing. Is this true? So I heard like the one of the training things they do in for the astronauts is they put them in the pool because there's almost zero gravity there, and they have to pick up certain stuff.
I don't know exactly, but I know there are some stations where actually you can create zero gravity, and the astronauts needs to be there before going there. So it's kind of you can consider it as a room. In that room, they create zero gravity. So if you enter to that room, you won't feel any gravitational force, and you are kind of floating around the room. So astronaut will experience this thing before going to outer space. And the question you asked about the pool and the chasing one or two things in the pool, I'm not sure about that.
Anyways, maybe I can go today or next year.
You can do what? Sorry?
Maybe I could work as an astronaut today or next year.
Yeah, I mean, of course, there's always room for everyone. Like if anyone is interested, you can uh, dig more into this thing, and you can find which path actually you needs to follow to be an astronaut. Like if that's your passion and you want to be an astronaut, of course you can search more on this thing. And as I have said in my video, it's not just today or tomorrow thing. You need patience. You need to be very patient to be an astronaut, to work in this field, right? So if you love what you are doing and you patiently working towards it, if Allah wish, inshallah, in one day you will be an astronaut.
Very good. Yes, Labi, he is also doing some kind of programming. He controls robots. So yeah, I hope he can also, inshallah, one day he will become an astronaut. Yes.
Sure. And to let you know, like a few days back, actually, students from Canadian students actually built a CubeSat and they sent it to the space. Yeah, I think McMaster University was working very involved in that. Yeah, so if you want to search more, you can just search CubeSat launched by Canadian students. You'll find lots of information over there. Yeah.
Rishi, can you share, because I think you went last year, right? At NASA to visit there, right? There's some kind of program.
It was in Houston. It was like a NASA museum.
Okay.
Yeah, there are lots of museums. It's better to visit those things. You can learn a lot, you can see a lot, and it will inspire you for sure.
I'll search some programs in I know in the summertime in different universities they run different kind of programs. I think the people who would like to be astronaut, maybe those kind of summer camp program, 1 week program could be available in somewhere. So I'll search and then let's see. I'll share it later. Okay, so if Arnav and Bikash, if you have any question, you can ask, you can write. If not, then maybe in 1 or 2 minutes, we'll finish our session.
Wait, can you send normal things to space? Because I thought I sent a drone to space one time.
What? Come again? What you?
So basically, can you send normal things to space like drones? Because I thought I sent one.
Oh, normal things. Like, of course, like you can send anything in that space if it's space grid, and it like what a drone is doing. Maybe there are loads of things in space. They're doing the same thing. They may not call it drone. And yeah, like surveillance and lots of stuffs, right? So yeah, but they may not call it drone, but yeah. And when you said space has different stages, like lower space, deep space. So if you just fly it for a certain height, of course you can call it space, right? And if you have to reach a certain distance to reach deep space. It's good to hear that you are very interested in space. Work towards it. Yeah.
Yeah. I'm making
You're making what?
nothing, guys. I was just making this motor thing,
Mhm.
and yeah, it almost flew, but it fell.
Okay. Okay.
Yeah, because it had too much weight.
Mhm.
Keep trying, and then let's say we have some local some engineers. Maybe we will solve it together, and maybe we can hire Dr. Manzur someday to come to Calgary.
Sure, I love to. I love to. I love to come.
Okay.
Thank you very much, Dr. Manzur, to give you time for us, and hope our students, our children, they will benefit from this program.
It's my pleasure. Thank you so much for inviting me. I really like that I talk with some young stars. It inspired me. Thank you for inviting me.
Okay, bye-bye. Hope see you again next time.
See you all. Take care. Bye.
Thank you.